Okay, so here in the folder I gave you 3 files that aren't, let's say, part of the training because they are more like ways for me to show you stuff. So you have CFP for curve follow project algorithms, curve follow project approach and retract movements, and curve follow project optimization parameters. So we'll go and open the CFP algorithm. But before we go there, I'm just going back. So when I'm talking about the algorithm, I'm talking about select algorithm here. So we'll see what's inside of that and what exactly does it mean. So if we go to CFP algorithms, you have 4 robots here doing 2 different tasks. So 2 painting robot and 2 cutting robots. And they all use a different algorithm of your RoboDK. So here you have a first ABB robot. If I open the curve follow project here, it's called minimum tool orientation chain because it's the name of the algorithm we're going to select. So if we go real quick, we have 4 algorithms: minimum tool orientation change, tool orientation follows path, robot holds object, and robot holds object and follows path. So if you run the minimum tool orientation change, you will see that behavior here. So the TCP is actively following the points, so there's no issue here. But you can see that the orientation of the tool with respect to the robot base stays constant. So that's the point of minimum tool orientation change. You're going to try to keep the tool always oriented in the same way. So that's very useful for stuff like milling. Generally, people use that also for 3D printing or other application like that, where you don't really care about the rotation around Z. You just want to follow a specific set of points. By default, if I just bring in the reference frame here, the default orientation, because you can play with the orientation, we're going to discuss that in this video, but the default orientation, if I just press escape, the default orientation will always be the same. So it will try to match the x-axis of the tool with the negative x-axis of the base. So as you can see, if I'm following the path here, it's always the same direction. So the x-axis of the tool is always pointing in the opposite direction to the x-axis of the base. So that's the first algorithm. Then we have tool orientation follows path. So if I open this curve follow project here, you have tool orientation follows path. If you select this one and you start it, you will see that the robot is following the same exact points, but this time we're following kind of the tangent of the tool, of the path, sorry. And it's really the tangent that we're following. So if we make that a bit smaller, by default, so this is the default orientation, the x-axis will always be pointing towards the next point. So if you're at one point, let's say, if you're at that point here, the x-axis is pointing towards this point here. If you go to the next point, pointing towards the next point, and then so on and so forth. So pretty much the x-axis is always tangent to the path we are following. So just like that. Next we have robot holds object, which is simply here, this one, robot holds object, and the result is the following. So the robot is just following the path around the piece, just like that. So like I already told you in the collision section, if you pick the part and move it around, this is what we call either fixed TCP, remote TCP, or robot holds object. And the last but not least one, robot holds object and follows path. So very similar to robot holds object, but this time it doesn't necessarily go the same. Let's say this one here rotates around the tool and the other one rotates more around the wrist. So that's a different approach to the same problem. So I can start all the robot at the same time. So I don't really know how many robots we can add in the station. I tried with many and it always worked. So I never reached really the limit on this one. So those are the 4 algorithms you can use for any of your either curve photo project, point photo project, robot machining project, or 3D printing project. Let's go back to our dispensing training station here. And let's reopen here for this one. And then, okay, I'm going to delete the program here. I'm going to explain you why I did so later. So here you can, like I said, select the right tool orientation. So in this case, I do believe that minimum tool orientation change is the best option I have here. It can be different if you have a specific nozzle. So if you have a nozzle that is potentially like tapered, or like have a 45-degree angle, or maybe is like this, so that you're kind of applying some kind of triangular profile along the path, you will need to use the tool orientation follows path. But in this case here, we're just having a standard round nozzle. So tool orientation, minimum tool orientation change will do the trick. So if you remember well, I just told you a few minutes ago that by default, the orientation of the tool when you're using minimum tool orientation change will always be that the x-axis of the tool will point towards the negative x-axis of the base. So both positive x-axis will be like moving in the opposite direction. That's something that you can change easily, but before we do so, I'm going to show you that you can click on Show Preferred Toolpath, and you will see this appearing. So this toolpath here will show you how the robot should behave along the path you selected. So as you can see here, because the x-axis is in this direction, the flange is necessarily pointing in the wrong direction, which creates that kind of weird motion where we are in this direction here and then rotates, because here it would be impossible to reach the position with the robot the other way around. So this way RoboDK kind of apply what we have optimization, our compensation algorithm or optimization parameters, to make the path a possibility no matter the limitations. We're going to talk about that later, but for now, if you click Show Preferred Toolpath, you can come here to Path to Tool Offset. You have Rod Z, so rotation around the Z axis of the tool. And if you take your scroll wheel, you can rotate that to a certain value. So let's say 180, click Update, Simulate, and now the path makes much more sense. There's still a small, let's say, motion here. This is because the robot is out of reach. We're going to discuss that in a few minutes. Here potentially because we're hitting a limitation on the robot. So if I'm just going to bring that here. So I'm going to explain you how it works, but you can see here when we're doing the little motion of the wrist, that's because joint 4 is reaching its limit. So that's not a big deal. We'll be able to correct that in a few seconds. And in fact, like just while I was talking, if my goal was to fix that already, it would have already been fixed. So that's not a big issue. But that's still real cool that you can just decide what orientation you want. You can enter value directly here. So I could enter like 90 directly here and have 90. Or I could simply bring the robot to a certain orientation. So I don't know, maybe like, oops. I'm gonna bring it closer to the robot here. So let's say I'm gonna stop that here. Let's say that I want a 45-degree angle like that. What I could also do is just bring it here and click Teach. That will apply that orientation to the tool. So that's another method. So I prefer having it straight for now. So I'm gonna go 90 degrees here, click Teach, Update, Simulate, and just like that, the path is followed. Okay, so that's great. That's how you can control basic orientation around the Z-axis. If you need to modify the orientation around X or Y, you can always just come here, click the drop-down menu, select another Euler angle format, and now you'll have access to modifying. So if you click show preferred toolpath, you'll have access to modifying X, Y, or Z. So you can give it a twist like that, a twist like that, let's say, and a small twist like that. That doesn't make much sense, but it can be done. So that's how you basically play with this feature and how you select a specific algorithm. So for this one, yeah, that's going to be enough for this video. In the next video, we're going to talk about approach and retract motion, because it's important to be able to go to a specific position and retract from that specific position without colliding with everything around yourself.